Uh, Welcome back, everyone. Next up, we have Usha R, who will give a session on performance test strategy in Unity project. So Usha joined ThoughtWorks last year through WAPASI program, an initiative to bring women back to work. So she has a total of 4+ years of experience as a quality analyst with a passion towards delivering quality products. So she is also excited to get herself updated with the newest technologies today. So over to you, Usha.
Thank you, Jancy, for the intro. Hello, people. Good evening. Let me share my screen quickly. Hope my screen is visible.
Yes.
Thank you, Jancy. I am here to present a lightning talk on the latest exploration done by me in the performance test strategy in Unity project. So let look into the agenda for today. Today I'm going to cover Unity intro, why performance testing is vital, and getting starting into the details, performance test metrics, tools available for the testing performance, and benchmarking performance from the test results. Let's move on to the introduction. Unity is a most popular cross-platform game engine, which helps to create 2D or 3D games and provides an interactive XR experience to us. Before going to the performance testing, let's let's understand some keywords of the Unity. First, I want to introduce you the scene. The scene is in Unity, we will call all the objects as game objects, and everything will be scenes and frames. So in scene, the scene holds all the game objects together. Whatever we can think, like it can be a main menu, it can be a different levels. So for a particular level, what are the environments you have added? What are the obstacles? What are the physics? What are the graphics, lighting effects? What are the things you have added? All together is referred as scenes. And rendering is how the things what we have created on the Unity project is rendered to the user. So what the user sees in her with the naked eyes with the device. So what we have, either this can be a mobile, what we have rendered anything, or using the glasses, 3D glasses, what you have seeing, what is rendered to the user. That is the final result. So physics is regarding to the object, we have to have a note on how it responds to the collisions or gravity or various other forces. Like if you drop a ball, it should flow towards downwards. So we have to, if there is a collision between two objects, that response we should be able to visualize. Those things are referred as physics. And frames. Here, frames is the final output that the user sees as an image. So in Unity, the frames will be executed one by one, so that we can get the visualization, or we will get the video as a whole, as a entire game or next AR VR experiences. So do anyone have any doubt in this basic concepts, or shall I move on? Okay, I guess now moving on to the next slide. Why performance testing is vital in Unity? We can identify the bottlenecks. So performance testing helps to identify areas of the game where the performance is not optimal, such as when we are having low frame rates or long loading times or strutting. Those things can be identified by this testing. And we can ensure the scalability. So what it means actually is how it can handle if there is an increasing number of players or complex graphical metrics has been included in the project without compromising the performance of the application. and we can improve the user experience. So as we are concerned with the 2D games or any games, user experience is the foremost thing which we concentrating on. So if the performance is poor, so it will be very frustrating for the users, and they will be have a chance to abandon the game. So we should give an enjoyable user experience for the players. The last one is we can save time and resources, like performance testing help to identify issues early in the development process, so before they become more difficult and costly to fix. So we can fix in the on the go, and we can save time and resource. Next, we can go to the life cycle, how we can do the performance testing. First thing, we have to set up a test environment. Our test environment should contain the scenes. We should contain the lightning effects, graphics, everything should be replicating the final production environment. Then we can define the metrics. So based on our project and requirement, we can define the metrics. We can also have the threshold. What should be the minimum threshold for this particular metrics? It will be differing based on our projects and requirements. And we can execute the test, and we can have a report for can be taken as a baseline for further references. Even also we can do a test, we can do a specific test elements, like if I want to test particularly on a particular scene, so I can execute a particular scene on different configurations or on different environment, like different OS, everything, and with different multiple number of players, I can test with the specific scenes or methods which I was targeting. And we can analyze the data. So we can identify the bottlenecks. And based on the identification of the bottlenecks, we can optimize the code, and we can refactor based on the bottlenecks we have identified. And after optimizing, we can retest it again, and we can have a comparison with the data that we have collected on the step 3. And we can repeat this process until we have achieved the performance what we have targeted. This is the simple cycle what we have going for performance testing. So let us look into the testing metrics for Unity project. The frame rate. So for any of the gaming project, frame rate is the foundation for any gaming project. So if the frame rate is more, the performance will be very high. So we should be always target for the higher frame rate. Rendering. So rendering plays a major role when we are going for the AR, VR and XR experiences. So in those things, we will have left and right eye. We will be having separate lenses. Those should be rendering with sync. Also, if you take the mobile games, like we should not get any black screening or white gray screens or any disturbances during the whole experience of the application. And also this is everyone will be known, for any game or any videos, the audio and video should be on the sync. And I have already spoken about what the physics is, so that should be also taken care. Input latency. This matrix is what is the latency period the user provides the input and the response that he got from the application. That should be very less, so that the performance will be high. The memory usage. If we take any game object, the memory will be quite consuming. So even though we have consumed more memory, our performance should not go low. We shouldn't compromise for any reason. And the last one is thermal rate. Thermal rate is what is the temperature of the device. So whenever we are playing any game or any AR VR thing. So the device will be get heated at a particular time. So we have to keep an eye on that. So how we can reduce the thermal rate. So if the temperature is low for a sustainable period, so the performance will be very high. Moving on to the tools available for performance testing in Unity. So let's look into some inbuilt tools, and I will list other tools available also. First one is Unity Profiler. In Unity Profiler, it gives a detailed metrics readings in a graphical manner. Next one is Unity Test Runner. Unity Test Runner is not just performance testing. It helps us to write the automation test, and this test runner is used for any kind of testings like unit testing, performance, integration, functional, any kind of testings. But we can use it along with Unity Profiler or other tools to write our automation tests. Next one is the Unity Performance Testing Extension. This is the one like a plug and play. We can add this extension in our project, and we can make use of Unity Test Runner to automate the scripts, and we can do the performance testing. Next one is the Unity Analytics. Unity Analytics gives more insight on how the user interacts with the applications. So other than inbuilt tools, we can also have Visual Studio Profiler and other third-party tools like JetBrains, Trace, Intel vTune, Amplifier, and NVIDIA Insight. So based on our applications, we can choose our tools. So here I'm going to talk mostly about the Unity Performance Test Extension, and I can show you how the Unity Profiler report also. So first look into the performance testing extension. So here we are utilizing Unity Test Runner and the performance testing extension. So we can get the Unity Test Runner by choosing the under the Windows tab, we can choose General and we can Test Runner. Then in the Unity framework, we will get the Test Runner tab. And how we can add the performance test extension is in our project under the manifest.json file, we have to include the reference form.unity test framework.performance under both dependencies and testables. And we have to add this reference using unity.performance testing on top of our script to enable those libraries work in our project. So what this performance test extensions provides several API methods which takes the measurement in our test, and depending on that, we can have the report of the same. So how we will be taking measurement in this performance extension suite. So it has the object sample group definition. It is a data type of struct. So it has different API methods under it. We can make use of them and we can have the measurements done. So first one under this is measure.method. This API method helps us to we can have a particular method can be iterated how many times we have required. We can have a strain on that particular method on different configurations or different setups, and we can get the particular methods metric. Next one is the measure.frames method. This API method helps to get the execution time of the each frames. If we have, say, we have 100 frames in our project, we can execute first 50 frames or last 50 frames in that way, and we can measure based on that. And even we can go for iterations for the frames also. Next one is the measure.scope method. This method gives the execution time of a particular scope. If you want to run for a particular method, it gives the execution time of that particular measurement which we are in scope. This we can use for both asynchronous and asynchronous methods. Next one is the measure.profiler markers. This profiler markers includes most of the CPU usage, memory usage, physics, graphics, all other markers will be included in this profiler markers. And last one is the measure.custom. If we want to have a test out of this for methods, we can customize based on your requirement. So this is the sample code that I have taken for the scene measurement. So here I have given as the unity test. This is the attribute which tells it is a test method. And this is the tag I have added for performance. So it will be added for the each performance testing. This method will be added. I have given the method name as rendering under sample scene. And I'm using the measure.scope method here. And I'm creating a new object with the name setup.load scene. So this setup.load screen will capture the measurements that I have required for this particular scene. So I am loading the scene. The sample scene is the name of my scene. Sample scene is the name of my scene. So I'm loading the scene using the scene manager. Yield return null. This is the waiting that we are providing just to collect all the measurements. After that, I'm giving the measure.frames.run. So I'm also taking the measurement of what is the frame per second, what is the frame time, everything I am testing. So in this particular sample, I am testing what is the load time of the particular scene and what is the FPS. So this is how you can see here. We can also have test for both play mode and edit mode. So you can see I have, this is the inbuilt default test we have in the extension thing. And we have, I have executed 26 tests, and you can see it have given the minimum value, median value, maximum value, average, what is the deviation, everything you can see for each tests. And also we can have the consolidated for the tests also. So here we can see this is the consolidated report for all the 26 tests that I have executed. And it gives the what is the standard deviation, what is the deviation point for our particular test, what is the median value, what is the minimum value, and what is the maximum value that we have got in our test. Next, let me move on to the Unity Profiler. So Unity Profiler will be, we cannot automate anything on that, but we can just have a graphical output of what's the performance for our particular project, and it will be more useful on the online multiplayer scenarios. So here we can see CPU usage, rendering, memory, audio, video, and physics. And if you see this chart, we can see the high points. So in the high points, it is orange color. So when we are referring to the orange color, it is physics. So at this point, the physics consumes most of the CPU usage. So this is how we will try to identify the bottlenecks of our performance, and we can work on that. I'm done with the presentation, team. I am open to the questions that you have.
Oh, thank you, Usha, for the informative session on performance metrics and the ways to create benchmarks as well. So we have question in chat from Shiva. I'll read it loud. Since the performance is completely dependent on the hardware, what is the standard procedure ThoughtWorks follows to determine on which all hardware these tests needs to be performed?
Okay. I'm not sure about the standard procedure of ThoughtWorks, but I'm in exploring the things for our project. So if we take on the hardware, like we can have SDKs, everything we will be having. So I'm not sure about the ThoughtWorks procedure for the.
Hey, can I take this question?
Sure, Jason.
Okay. Okay, sure. So, if I understood your question right, so is there any procedure that ThoughtWorks follows to determine the hardware's performance? Is that right? Okay. Okay, so we are working on specific devices, Shiva. It is not about all the hardwares that we are considering. Actually, we are developing games and applications for specific devices. To that specific devices, we are not into the hardware level of testing. So we are just, we have this scope of, determining the frame rates, the Unity's performance. So there are two performance involved. One is the hardware performance, and the other one is the Unity side of performance. When I say Unity side of performance, what is the frame rate? What is the CPU? I mean, what is the frame rate? And what is the graphics content? Whenever there is a huge graphics content, how it impacts the performance and those things. So we are into the Unity level of performance testing, and we are trying to spike out on the hardware side as well. Maybe we will come with the hardware side of the stuff in the upcoming events, maybe. And since you have asked for ThoughtWorks things, it is not, I mean, really ThoughtWorks defined things. We are just trying to understand from Unity's tutorial and things. Maybe going forward or in the future, maybe we might try to identify the different best practices on the procedures with Unity, and maybe we will come up with the sessions then. So now it is just a session for it's just an overview, an eye opener for the Unity's performance testing. Any other questions?
Thank you, Jayachandran, for pitching in. So folks in the office, do you have any questions?